Hey guys, Victoria here and welcome back to my channel. So in today's video, I'll be showing you how to write and balance any chemical equation, and I'll also be going over the stuff that you need to know before you even start writing a chemical equation. So I hope that this video can help you. So the first thing that you need to know before you write or balance any chemical equation is this table right here that I will be showing you later. And this table consists of all the formulas for positive and negative ions. Everything is here. Take a screenshot if you want, do whatever. Just memorize all the formulas here, because if you don't know the formulas, there's no way that you can even write or balance chemical equations. So memorize these for chemistry. It's so important. The second thing that we have to know in order to balance any chemical equation is the cross method. So the cross method is actually used to determine the products first. Before you actually balance the chemical equation, you need to at least know the product. So I'm just writing down product in brackets. And then for this example, I'm actually using zinc and oxygen as the reactants. So then I'm just writing down a simple chemical equation where zinc plus O2, you get ZnO. But then the problem is now you're not sure of the product. Is it Zn2O? Is it ZnO? Is it ZnO2? So you're going to determine this by using the table that I showed just now. You need to know the formulas for the ions. So once you refer to that table, you'll know that you have Zn2 plus and O2 minus. And the cross method is used by crossing over the charges on top. So 2 will go to the oxygen and 2 from the oxygen will go to zinc. But once you cross the 2, if it's the same number, then you can cancel off and the product is simply ZnO. And now that you have determined the product, you just need to make sure that the amount of elements on both sides of the arrows are the same. Before and after the arrow, zinc must have the same amount, O2 must have the same amount as well. So as you can see, there's only one oxygen after the arrow, but there are 2 before the arrow. So that is why we have to multiply by 2. But once you multiply the oxygen by 2, you have 2 zinc as well. But before the arrow, you only have 1 zinc. So that's why you have to multiply the zinc before the arrow by 2. And there you have it, a balanced chemical equation. So this is the basic of balancing any chemical equation at all. So if everything works the way number 2 does, then it would make things so much simpler for us, because we can simply look at zinc and oxide and we can determine the product, zinc oxide. But unfortunately, that is not the case for most chemical equations. Often there are multiple products and we need to memorize what those products are. So in the rest of the video, I'll be going over the general chemical reactions that you need to know in order to write chemical equations. And the third one is the chemical reaction of group 1. So group 1 are made of alkali metals, and you need to memorize that alkali plus water, you get metal hydroxide plus H2. The example that I used here is lithium. When lithium is added to H2O, you get lithium hydroxide, which is LiOH plus H2. And then I'm just balancing the chemical equations. So you should start balancing this by balancing the H, since there are 3 H after the arrow and only 2 H before the arrow. So you're going to multiply LiOH by 2, so you'll get 4 H, and then you have to multiply H2O by 2 in order to get 4 H as well. And once you do that, you will get 2 lithium, and that's why you are putting 2 in front of the lithium. Another chemical reaction of group 2 is that alkali metal, when added to oxygen, you'll get lithium oxide, and I'm using the cross method again to determine the product. And as you can see, the 1 from Li goes to O, and then the 2 from O goes to Li. So the product that you get is Li2O based on the cross method. And then again, I'm just balancing the chemical equation once I get to know the product. The last chemical reaction of group 1 is that when alkali metal is added to chlorine, metal chloride will be produced. And I'm again using Li as an example. So Li plus Cl2, and to determine the product, I'm using the cross method again. Li plus Cl minus, when they cross, they'll cancel each other, so you get LiCl. Once you know the product, just balance the chemical equation like you would balance any other chemical equation. So there are 2 Cl, so multiply by 2, and you'll end up with 2 Li, so multiply Li by 2. The fourth thing that you need to know in order to balance chemical equation is the chemical reaction in group 17. So in group 17, when halogen is added to water, 2 acids will be produced, but there are different kinds of acid. So the example that I use here is Cl2 and H2O, and it will produce HCl and HOCl. You don't need to balance this chemical equation because it is already balanced. So yeah. The 2 other halogens which can undergo these reactions are bromine and iodine. The next thing that you need to know is halogen when added to NaOH, you will get NaX plus NaOX plus water. So X could be Cl, Br, iodine. And then the example that I used here is bromine. When NaOH is added to Br2, NaBr, NaOBr, and H2O are produced. And unfortunately, there is no shortcut when it comes to this. You just have to memorize the products of these chemical reactions. That's just the way it is. And then the third thing that you have to know is that when iron is added to halogen, iron 3 halide will be produced. So the example that I used here is iodine. So iodine plus Fe, you produce FeI3. Again, I use the cross method, but you can't really see it. But yeah, the cross method, and FeI3 is obtained as the product. And then I'm just balancing the chemical equation as usual. The fifth thing that you have to know is the chemical reactions across period 3. So the first one is that when metal oxide is added to water, an alkali is produced. And the example that I used here is Na2O. So when Na2O is added to H2O, NaOH will be produced. And you can use the cross method to determine this as well. Na plus, the charge is 1, OH minus, charge is 1. When you cross it, you will just get NaOH. So I went ahead and balanced the chemical equation in a different color. And the next thing that you have to know is that when non-metal oxide is added to H2O, an acid is formed. And an example of non-metal oxide is silicon oxide. So that's why I'm writing down. And you will obtain an acid, which is H2SiO3. And the chemical equation is balanced by itself, so you don't have to balance it. The sixth thing that you have to know is the chemical properties of acid. This is very common. So the first one is that acid, when added to metal, salt and H2 will be produced. The acid that I use here is nitric acid. So HNO3 plus Mg, you'll get MgNO3 2 plus H2. And then you have to balance the chemical equation by putting 2 in front of HNO3. The next thing that you have to know for acid is that when acid is added to base, salt and water are formed. I'm sure most of you are familiar with this. This is a very popular one. So I'm just using HCl and NaOH as an example. So you'll obtain NaCl, which is a salt, and water. The last one for acid is that when acid is added to metal carbonate, salt and water and CO2 will be obtained. I used HNO3 as an example again. And then for metal carbonate, I use PbCO3. So to obtain the product, you can again use the cross method, and the rest of the products are already written for you. So you have to add water and CO2. The last step is just to balance this chemical equation. The seventh thing that you have to know is the chemical properties of alkali, and the first one is actually repeated from acid just now. So the first one, alkali, when added to acid, you will obtain salt and water. I used a different example this time. I used potassium hydroxide. So KOH plus HNO3, what you will obtain is KNO3 and H2O. The second chemical property of alkali which you need to know is that when alkali is added to ammonium salt, you will get salt and water and ammonia. And this is a bit of a complicated equation, but in case it comes out in your exam, this is what you have to do. So the alkali that I use here is barium hydroxide, which is BaOH2, and the ammonium salt that I used here is ammonium chloride. And so you have to obtain the salt BaCl2 and ammonia and water, and you have to go ahead and balance this chemical equation. I know this is quite complicated. You might have to take some time to understand and go through this one. The third property of alkali is that when alkali is added to metal ion, an insoluble metal hydroxide will be formed. So the alkali that I use here is NaOH, and the metal ion is Cu2+, but we're using CuSO4. So that is why you'll be obtaining two products, CuOH bracket 2, and you get Na2SO4 as well. So the basis of anything is still the cross method. So the cross method is super important still, along with the chemical reactions of everything. And number 8, you need to remember that all carbonates decompose to form CO2 except for K2CO3 and Na2CO3. This is actually from the salt chapter, and there are a lot of properties of salt and all that, and this is one of it. So when CaCO3 decompose, you will produce CO2 because this is the rule, right? So you can write down CO2, and the rest of the stuff left, you will get CaO. You get what I mean? Like CO2, once you bring out the CO2, you will have one Ca left and one O left. So that is why you get CaO. As simple as that. Number 9 is the fact that all nitrates decompose to oxygen and nitrogen dioxide except KNO3 and NaNO3, which decomposes to form oxygen. So when KNO3 decomposes, oxygen will be formed, and I'm using this as an example. KNO3, and then arrow, and then I write the product down, oxygen. And what is left after oxygen is taken out? It is simply KNO2. And so I have to balance this chemical equation because it is not balanced. And then we'll move on to number 10. Number 10, sulfates decompose to form sulfur trioxide. So the sulfate that I used for an example is zinc sulfate. So I'm just writing that down, and then after the arrow, I'm writing sulfur trioxide. First, made a bit of a mistake there, that's why I correction taped it. So there's sulfur trioxide. And once you take out sulfur trioxide from zinc sulfate, you will be left with one zinc and one O, and that is why the other product is zinc oxide. Number 11, and it is the last one, is that all chlorides do not decompose except for ammonium chloride. So I'm writing an equation for the decomposition of ammonium chloride. when ammonium chloride decomposes, it will actually form ammonia and an acid, as you will see later. So NH4Cl decomposes, ammonia will be formed. And once NH3 is formed, the only thing left is simply HCl. So those are the 11 things that you have to know in order to write and balance any chemical equations. I've plugged all those information from the chapters in Form 4 and Form 5. And I know that there are a lot of stuff to memorize, but chemical equations are a huge part of chemistry, and I hope that you will really take the time to try and memorize it. Do what you can, just try your best. And that's all for today's video. As usual, I hope it was useful. Thanks for watching, and I'll see you in my next video.